Welcome back to my channel. So how do you solve this integral? So this integral, we can solve this by using the double angle identity. We know from the identity that cosine of A cosine of B is the same as 1/2 cosine of A plus B plus cosine of A minus B. You know from this identity, so we can use this identity to really find what cosine of 2x times cosine of 3x is. So that is going to be 1/2. This is the cosine of A plus B. A is 2x and B is 3x, so that is 5x plus cosine of A minus B, that is going to be 3x minus 2x, that is going to be x. You can also do 2x minus 3x, that will be cosine of negative x, which is the same as cosine of x because cosine is an even function. So this really is how this one can be broken down into. So this is 1/2 cosine of 5x plus 1/2 cosine of x, right? And we are going to multiply that with x. So we have cosine of x, cosine of 2x, cosine of 3x. This one is really going to be multiplied to this one now. So we are going to have 1/2 cosine of x times cosine of 5x plus 1/2 cosine square x, because cosine x times cosine x is cosine square x. And we can utilize the identity here again. So this is going to be 1/2. Utilizing that again, that is utilizing this one again. Here we are going to have another 1/2 cosine of a plus b, which is x plus 5x, which is 6x plus 1, plus cosine of a minus b. What is a? A here is 5x and b is x, so that is going to be 4x. That is subtracting them. Plus 1/2 cosine square x, like that. Okay, so that is going to be 1/2. So 1/2, that is going to be 1/4. Then we have cosine of 6x plus cosine of 4x plus 1/2 cosine square x. But we know that cosine square x is the same as 1/2 1 plus cosine of 2x, like this. So we can plug that in to our integrand. So that is going to be 1/4 cosine of 6x plus 1/4 cosine of 4x plus 1/2, and this one is 1/2 1 plus cosine of 2x, like this. So we have 1/4 cosine of 6x plus 1/4 cosine of 4x plus another 1/4 cosine of 2x, that is this half multiplied by this half multiplied by that, and then plus 1/4. So this is how our integrand can be broken down into. So this one, which is our integrand, is the same as this one. So we can now integrate this one quite nicely. Okay, so the integral from 0 to 2 pi of cosine of x cosine of 2x cosine of 3x dx. This is the same as the integral from 0 to 2 pi of 1/4 cosine of 6x plus 1/4 cosine of 4x plus 1/4 cosine of 2x plus 1/4 all this dx. So we are now ready to integrate. So integrating them term by term, so that's going to be 1/4 the integral of cosine of 6x. We just have to integrate sine cosine, which is sine of 6x. Then we differentiate the angle, which is 6x. When we differentiate, we'll get 6 When we differentiate the angle, we get 6, and then we divide by 6. That is how we integrate that. Plus 1/4 sine of 4x. Then we differentiate the angle, which is 4, and we divide like this. Plus 1/4 sine of 2x. And then we differentiate the angle, which is 2, and we divide plus 1/4 x, like that. So this one is really 1/24 sine of 6x plus 1/16 sine of 4x plus 1/8 sine of 2x plus 1/4 times x. And we are integrating that from 0 to 2 pi. This is integral from 0 to 2 pi. I didn't write that. Okay, so now we can plug in our limits. This is sine 2 pi. That is sine of 360. Sine of 360 is 0. So sine of 360 is 0. So multiplying by a whole number, that is going to give you sine of 6 times 2 pi, which is going to give you 0 as well. So we have sine of 6 times 2 pi is 0. Sine of 6 pi, 4 pi times 4 times 2 pi is 0. Sine of 2 times 2 pi is 0. So all of this is 0. The upper limit is only going to be left with 1/4 times 2 pi minus, when you plug in 0, sine of 0 is 0 for everything, including this. So that is going to be 0 as well. So that really reduces to pi over 2. So that is the answer to our integral. So if you integrate 0 to 2 pi of cosine of x, cosine of 2x, cosine of 3x, dx, this one evaluates nicely to pi over 2 quite nicely. So that is how we integrate this. So we first start off by using the double angle identity in order to break this one down into something that can easily be integrated. And the answer down there is pi over 2. So if you find this helpful, please subscribe to my channel, smash the subscribe button for more engaging content from Calculus Diaries. I thank you so much for watching this video, and I will see you in the next one. Bye bye.